Today in the lesson we continue to write fractional numbers as decimal periodic infinite fractions. First example, the fraction is 1/6. We need to write this fraction as an infinite decimal periodic fraction. To do this, we divide 1 by 6. Let's do this division in columns. Let's write it down. 1 divide by 6. 1 divided by 6, that's 0 whole. 0 times 6 is 0. 1 minus 0 is 1. We add 0. In this case, we put a decimal point. 10 divided by 6. We take one of each. 1 times 6 is 6. 10 minus 6 is 4. We add a 0. 40 divided by 6. Take 6 each. 6 times 6 is 36. 40 minus 36. That leaves 4. Add another 0. 40 divided by 6. One more time. By 6. 6 times 36. And we can see we're back to 4. If we add 0 and divide each time we divide 40 by 6, we're left with a remainder of 4. So what I can say is that 6 will be repeated many times. Notice that in this case, I will first write down the answer 0.1. And only the number 6 will be repeated an infinite number of times. So then this 6 will be considered a periodic number, that is, the period of this fractional number. Now let's write it down in the form of an infinite decimal periodic fraction. 0 integers, we write down. The number 1 does not repeat, so I write it down. But the number 6 repeats, so I write the number 6. I write it in parentheses. So what I'm saying is that this is the period of our fractional number. Or you can write it like this, 0.0. 1/10 and 6/100ths of a period. Notice I will only put that sign above the number 6. I'm talking about the number 6 being repeated. Notice that when we did the examples, we had a decimal point right after the decimal point. The digit that was repeating. But in a decimal infinite periodic fraction, it is not only the number immediately after the decimal place that is repeated, but also those numbers in other positions. Be extremely careful. And now let's look at another example. 5 whole 7/36. Note that in this example we have a mixed number of 5 integers and 7/36. In the previous examples we didn't have mixed numbers, but we had the correct fractional numbers, so we got 0 integers in the answer. What should we do in this case? The thing is, we can write this number as 5 plus 7/36. 7/36. The number 5, I'll leave it. But the fractional number 7/36, I'm going to write it down as an infinite fraction. Therefore, we'll divide 7 by 36. Well, the result is, of course, 7 is not divisible by 36, and we'll write down 0. 0 times 36 is 0. 7 minus 0 is 7. We add 0. 70 divided by 36, we take one of each. 1 times 36 is 36. 70 minus 36 is 34. We add 0. 340 times 36. Let's multiply the number 36 by 9. 9 times 6 is 54. Write 4, memorize 5. 9 times 3 is 27, and 5 is 32. Subtract. 0 minus 4 is 6. And 3 minus 2 is 1. Add 0. That's 160. As you can see, we don't see the same remainder, so we keep going. We need to divide. 160 divided by 36. Let's take 4 each. 4 times 36. 36 times 2 is 72, and multiplied again by 2 is 144. 160 minus 144 is 160 minus 144. 6 and 1. Notice we again get 16 in the remainder. We add 0 again to check, and once again we take 4 each. 4 times 36. And that's 144. And once again we have 16 in the remainder. Then we conclude that every time we divide, we're going to have the number 4. The number 4. Then we can conclude that the fractional number, let's say 736, is 0 whole. 19 we have digits do not repeat, but the digit 4 has a repetition. So we'll write the number 4 in parentheses. And then the result is, let's go to our example. 5 plus 0 decimal point, 19 and 4 in a period. The result will give us the following number. To 5 whole ones we can add 0 whole ones, so I write 5 whole ones. 19 and 4 thousandths. In the period. Applying the algorithm for converting an ordinary fraction to an infinite periodic decimal, we can write down the fractional number as an infinite periodic decimal. But I'd like to point out that when you divide the numerator by the denominator, there is an identical remainder. That is, it is not always possible to write an ordinary fraction as an infinite decimal periodic fraction. If you noticed, the digits don't repeat. There's no period in that number. It's not a periodic fraction. We will talk about it in the next lessons. And that's all for today. Goodbye. See you again.